So today we've got a set which isn't going to take much sorting out at all. It's a LCL Communicators NI440DX. It's already been sorted out by Noxyman, so he knows exactly what he's doing. He's qualified to do it, and all that's happened is the high-low power switch at the back has failed. So it's one of those things, and we've got a scrap chassis. So my job is to change that and make sure the set's working properly. We're still going to go through an alignment process because we're going to end up with different, slightly different techniques, etc., for the right end, shall we say. Now, one of the problems with these can be the relay, and Paul has put one of his alternatives in. Why didn't I solder the... Why didn't I put the soldering iron on? So these radios normally do about 3.2 watts and they receive well. They always sound nice to me, and everybody who isn't me says they're a bleed over box, but I think they're lovely. I've said many times before, I was once asked to get one of these as a wedding present for somebody. And this is the later one with the clear meter rather than the one with the yellow meter. One day we'll compare the yellow meter version with the white meter version. Now, I do have these relays, and one of our forthcoming attractions is to fit a relay. They are £10 to me trade. There we go. Don't need to look at anything like that. So in this Ziploc bag, hopefully we've got a microphone. I'm going to use standard replacement mic rather than the factory mic. And something that we've got here is the proper connector, which is so hard to come by. We'll get that connected to our crocodile clip lead, and then we'll look at how the switch is being a swine. So the pin out on these is standard Cybernet wiring, even though they're nothing to do with Cybernet. And this isn't some kind of game where I can get 0.1 of a watt more than Noxyman, or I can get 0.0000 something microvolts more. He knows what he's doing, and as I say, he's fully qualified to do it. Right, power supply on, picture in picture on, radio on, channel 20, 3 watt scale, better plug the equipment in. So that's clearly low power, 210 milliwatts. Yeah, it's always in low power. Right, we'll turn the power off. So pretty standard slide switch. It's been used double pole, so that was the right thing to do. And all I need to do is to locate a scrap chassis, and we'll pinch it. I was kindly given this chassis by another dealer, one which needed a relay. So he's had plenty of bits off it, which is great. We've got a switch. So can you see it's being wired double pole? So both the single pole switches are connected together. That increases its reliability. So we'll get this connected up and hope that's restored 4-watt operation. Just pause the video. Okay, so now we'll go back into transmit. That's low power. That's high power. Is that the right way around? Yes. It's got 3.5 watts. .5 3.5 low power. It's channel 20, 320 milliwatts. And the power consumption 1.32 amps. Transmitted audio, wow, looks about 2.6 on here, so we'll just look into that. Frequency only been on about 20 minutes, so we'll take this with a pinch of salt. Seven 79091. We're still coming up. And of course this can have been serviced 2 weeks ago and I could still find something to do to it. It's like tuning church organs. I can finish tuning the organ and think, oh, that note's not very much in tune. So you go back in and tune that in. Oh, well, this is just continuous, isn't it? Continuous battle. Right, receive. Scroll somewhere on here. Need to plug the test gear in. I also need to plug the PA speaker in, just do a quick check on that. That's that one. switch to PA.
Testing 1 2, testing 1 2.
Back to CB. Signal generator on. We've got 0.84. Not 0.8. One. Full squelch. 300 microvolts. Minimum squelch. .82. S9 shows we have it a little bit more than that. If it goes, it was 160 microvolts we've got, and on transmit the meter's supposed to be in the centre of the red zone, which it is. So I'll go through the transmitter. Don't think we touched that. I'll check with the circuit later. So still at 3.5, exactly the same, which is what you'd expect. Not sure why that's so springy. It's just a scrap chassis. No, it's not a springy, it's kind of got stretched. Oh, got it to 3.6. Things like this just to watch. Good, right. Go through everything else in a bit. Just check the receiver. So the detector arrangement's weird on these. Let's go through the front end. A bit more on. This one's the amount of 10.695 that goes to the IF. I don't think we've got any different, but let's have a look. 0.78. .75. 1. We're just dancing around the edges. Right, I'll come back to this with a note of which presets do what, rather than just haphazardly go through them. And when we'll check its on frequency in about half an hour. Okay, so we'll start by checking deviation with the test set behind me. Wow, actually it's a little bit high. 3. Wallow. There we go. Wallow. Yep, right. So let's see where we are with frequency. Well, of course, that's spot on, isn't it? But we'll nevertheless bring it up to where we are. There we go. So low power. Super duper. Transmit meter. Let's go over to the main meter. Centre of the red zone. S meter. 100 microvolts on the radio. We'll just pop that up a little tiny bit. So it just leaves us with the squelch, and then I just need to make sure with the circuit that that is done with the spectrum analyzer. So full squelch on the radio. And we'll adjust that for 100 microvolts maximum. No, it's already at its most sensitive. So our most sensitive position, go to the threshold. .78. Right, so I'll just check with the circuit diagram and just make sure we're not overlooking that coil. L4. Okay, so that one is done with the spectrum analyzer. So that is it. I'll just check our power. You know what? I'm going to say 3.8. When cold, and it was cold when I tested it initially. See if it's something like on the other channels. Yeah. So we're just running around 1.266, so I'm getting a little tiny bit more power for a little bit less electricity consumption, so you know, I've just skirted around the edges. In reality, I'm here to just check this is spot on, and it's spot on. But I've got to tune it to make sure that it's spot on, if you understand that. Not like the factory where they align things up to a line on a meter and it goes out on the conveyor belt. So it's certainly one of the better examples. I don't think I've ever seen 4 watts out of one. It really doesn't matter anyway. But they're normally somewhere around 3.2, 3.5. So there we are. Always really good transmitted audio. I'm just going to check that we actually have transmitted audio with the supplied mic. Wallow. Helps with on channel 20, doesn't it? Wallow. Yeah, it's spot on. It's one of the best sounding audios there is. Wallow. Yep. Marconi test set showing all the right figures now, but it wasn't half an hour ago on the deviation meter, which, as I say, needs the capacitors doing, but it's not going to happen. These are never the most sensitive sets. They're on a par with Maxcom 4Es and audio and and Uniden chassis. That kind of sensitivity, which are better than 1 microvolt. So as you can see, we got 0.78. But it's not going to be Binatone 5-star, which is probably you can get 0.25 out of. But does it make any difference, you know, with the noise floor? I think the one I've got planned is a Planet 2000, the one which needs the relay changing, which I've ordered a relay from the Far East. Roger. Well, not much difference there, is it? It's the usual. Right, we will do an on-the-air test later on. and I'm sure it's going to sound absolutely splendid. So thank you for watching. LCL Communicator NI440DX from 1981. Really here just to change the high-low power switching to make sure the set's working properly, which it is.